India's successful launch of Chandrayaan-3, its third lunar exploration mission, took place at the Satish Dhawan Space Center in Sriharikota, Andhra Pradesh. This mission focuses on achieving a soft landing on the moon, a goal that was attempted during Chandrayaan-2, but unfortunately resulted in a mission failure. Simply put, the objective of this mission is to land on the moon with precise control, ensuring no damage occurs to the lander. If the Indian Space Research Organization successfully executes this mission and explores the moon's south pole through Chandrayaan-3, India could potentially become the first country to substantiate the actual narrative of Earth's birth with the gathered data. In this video, we will explain why Chandrayaan-3 will take more than a month to reach the moon. We will also discuss the lessons learned from past mistakes and the improvements made. Lastly, we will talk about why this mission is important for the Indian economy. Stay tuned as we address these intriguing questions comprehensively. Chandrayaan-3 mission is an interesting and challenging endeavor. Landing softly on the moon is actually more difficult than landing on Mars. Only 11 countries have successfully sent missions to the moon, and out of those, only the United States, Russia, and China have achieved a soft landing. In comparison, Mars is farther away from the moon. Out of the 5 countries that have sent missions to Mars, only 2 have successfully landed there. Chandrayaan-3 is taking longer to reach the moon compared to missions from 50 years ago, when the Soviet Union and America reached the moon much faster. The time it takes to reach the moon depends on the rocket design and the spacecraft's speed. India doesn't have a powerful rocket like the ones used in the past, so they are utilizing Earth's gravity to help Chandrayaan-3 move towards the moon. This approach is more cost-effective and aligns with India's reputation for accomplishing great work on a limited budget. When a spacecraft is heading to the moon, if it goes off course, it becomes harder to control and fix its path in a short amount of time. The limited time and distance make it difficult to land the spacecraft safely. Additionally, the moon's lack of atmosphere requires powerful thrusters for a safe landing, which can potentially damage sensitive instruments. The south pole of the moon, where Chandrayaan-2 was supposed to land, has more craters and mountains, making it challenging to find a suitable landing spot and control the descent. The harsh temperature at the south pole can also pose problems, such as long periods of darkness that reduce the effectiveness of the lander's solar panels. However, Chandrayaan-3 has identified a better landing spot on the moon with a smoother surface and fewer obstacles, as well as more moderate temperatures. This reduces the chances of encountering problems during the landing. After the launch, Chandrayaan-3's initial orbit will be raised by circling the Earth 5 times to achieve optimal speed. This approach minimizes fuel consumption in the early stages of the mission, preserving fuel for the landing phase. Instead of following the traditional direct lunar surface landing method, ISRO has devised a unique plan for Chandrayaan-3. To avoid disturbing the lunar environment and compromising data collection, the mission will employ a slingshot-like maneuver to propel the spacecraft towards the moon. Subsequently, it will enter a decelerating orbit around the moon to significantly reduce speed before landing, allowing for a thorough inspection of the landing site. These 2 steps, orbital maneuvers and careful site selection, aim to overcome the challenges encountered in the previous soft landing attempts. Furthermore, Chandrayaan-3 will address communication issues by deploying a rover to probe the lunar surface. The lander will remain in a strategic position, receiving and relaying signals between the rover and Earth while exposed to sunlight. Comparing Chandrayaan-3 to Chandrayaan-2, the design remains largely unchanged. Let's explore the key aspects of Chandrayaan-3 step by step. 1. Payload. Unlike the 2019 mission, the payload for the 2023 mission includes only the lander and rover, as the orbiter from the previous mission successfully completed its objectives. 2. Enhanced lander. Lessons learned from Chandrayaan-2 have led to improvements in the lander, including reinforced legs to withstand impacts, increased engine power for proper speed reduction, and the incorporation of a hazard detection system. 3. Instruments. Chandrayaan-3 will feature an instrument called spectropolarimetry of habitable planet Earth. This instrument will help us discover smaller planets by studying the light they reflect. By doing so, we can explore a wide range of exoplanets and determine if they could be habitable or potentially have signs of life. 4. Launch Vehicle. The use of the LVM-3 launch vehicle, which can accommodate 30% more weight than the previous GSLV Mark II, demonstrates India's capability to launch heavier payloads into space. 5. Cost. Chandrayaan-3 has a reduced budget compared to Chandrayaan-2, showcasing India's progress and development in space exploration. Chandrayaan-3 is not only important for India's space program, but also for its economy. Successfully demonstrating ISRO's capability in soft landing opens the doors for India to undertake crucial international space projects. Just like NASA, we can engage in similar endeavors and generate revenue. By studying the craters in the Moon's South Pole region, Chandrayaan-3 can gather important information about the origins of our solar system and potentially discover valuable resources such as water, hydrogen, oxygen, methane, sodium, and silver. This location could serve as a significant stop for future space missions. The success of Chandrayaan-3 will showcase India's improved technology and contribute to the country's reputation in the global space community. If you found this video informative, please show your appreciation by liking and subscribing to the channel for more content like this. If you're interested in NASA's James Webb Space Telescope, click on the video. Thank you, and see you soon in the next video.